Hi, this is Pradeep Sharma, and today I'm going to demonstrate the Weka tool using DM processes. So let's get started. Let's have a quick look at the dataset. Our target variable is occupancy, and we are going to predict it on other variables such as temperature, humidity, light, CO2, humidity ratio. Moving forward, let's import this dataset to the Weka tool. For that, we have to launch the tool. Let's click on open file. This is my dataset.csv file. Let's import it with a simple click. This is my extra column, so I'm gonna remove it. I don't need it in this prediction. Okay, let's click on the occupancy. This is my target variable. Here we can see that we have the total count of occupied rows are 1141 and not occupied. So now we have our data imported. Let's explore this tool a bit. First, I'm going to click on this option, visualize all. Let's maximize it. Yeah, so here we can clearly see that light and CO2 and humidity are the good predictors, as they comprise out of 2408 rows. The light contains 2299 rows, 1478 rows lie in the CO2 area, and 750 rows light in humidity ratio. So we can predict roughly from this pictorial representation of the data that these three factors can be very good predictors. Let's move forward and explore this tool a bit more. So I'm gonna demonstrate the visualize tab. In this tab, we have scatter plot of one variable against another variable. So you can always see that occupancy against temperature, humidity, light, CO2, humidity ratio, and we can always maximize any of the scatter plot and see how the data lies between these two variables. Well, out of all the data, we are more interested in occupancy and its relationship with different variables. So let's have a quick look on all the variables which are contributing to predict the occupancy today. So this is the humidity ratio, and we can clearly see that the relationship between them. In the same way, we can see that CO2 is also has a relationship between occupancy and the CO2 like this. So all the factors against all the factors are plotted here in this tab. Let's explore the another tab. Select attributes. Uh, we will see how good all the predictors are in this tab. For that, let's choose correlation attribute eval option in this. Oh, it's already selected. Yeah, in search method, we have to choose ranker. What ranker will do, it shows the rank of all the predictors which will be using to predict the occupancy. In my thing, it's already been selected. Okay, so we are using this use full training dataset option, and this is our target variable occupancy. Let's start. So we can clearly see that it is ranked 93% of uh, of the prediction can be used using the light variable, 80% of CO2, and 6% in temperature, and 35% is humidity ratio. Let's move to another tab. The next tab which I'm going to demonstrate is classify. We are going to see two options in this. First, we'll choose 0R. We are choosing 0R to see the baseline of our model. Okay, so for that, I'm just choosing the 0R, and we'll just start. Okay, so the results are showing that correctly classified instances are 66.85%. So this is at the baseline of our model. The accuracy for model will be always more than this. Apart from the accuracy, the other factors like root mean square error, is also quite high, so we are moving forward with this model. We can always do some experiments and and take various examples such as 65% of training data of our model. Let's see how it will affect the accuracy of the model. It didn't affect much. Let's take it 40% training data and 60% test data. See, yeah, so it affected our accuracy from 99% to 98%, although the model is quite accurate. One important thing we can share here, like clicking clicking right on this tree, and we can see that this is, let me put it to screen. Yeah, so this is our decision tree on which we can easily see that light is the main factor on which we are getting splitting the nodes, and moving forward there are the different factors like temperature, CO2, humidity, again light. So we can see that light is the main factor on which we are doing the splits. So this is the most important factor on which the occupancy of the room lies. So we have made our model already of 3500 rows, saw the rank of different predictors, out of which light is the main factor on which you can predict whether the room is vacant or not. Let's see let's see a quick recap what we have done. We have imported the data set from this open file option. We visualized all the factors against all, and took a rough idea on which factor the occupancy can be dependent. We visualize all the data using scatter plots, and we calculated the rank of each factor. We we calculated the baseline of the model. We calculated the accuracy of the model. We changed the split percentage, and so on, and saw how the accuracy of the model differs. So that's all from this demonstration. uh, I'll see you in the next video. Thank you.